Hello, everyone, and welcome to the relaunch of Simsol webinars. My name is Nicole Neese. I'm the marketing director here at Simsol Software. When it comes to damage caused by natural disasters like hurricanes, it's sometimes tricky to identify whether that damage was caused by water or wind. For this webinar, we have a special guest, Erik Moore, a senior engineer with over 20 years of experience. He's going to be providing us insights on how to identify water damage from wind damage. Without further ado, I'm going to introduce you, Erik, and we also have Danny, our Director of Training, accompanying him. They're going to be having some great discussions. All right, take it away, guys.
All right, well, good afternoon, everybody. This is Erik Moore. As the presentation says, we're going to talk about wind versus water or wave damage. And I start off with this quote from Sir Francis Bacon back in the day. Nature is sometimes subdued, but seldom extinguished. And when you're talking about wind and waves, I think that's very appropriate. So when we talk wind versus water, it's important to realize that water weighs 768 times more than air. Just for instance, if you had a plastic gallon milk jug sitting on your table, empty, but it's full of air, that's pretty easy to pick up. But if I have a gallon of water in the same jug, that weighs about 8 pounds. So you're talking about a substantially more dense liquid in water than air. And when you run through the higher math and all that kind of fun stuff, the pressure of 1 square foot of water traveling at 10 miles an hour is about 209 pounds a square foot. That's quite a bit of pressure. When you consider that when we work the math backwards, that 1 square foot of water at 10 miles an hour is basically the equivalent of about 278 miles an hour in wind. So when we take that 278 miles an hour to the enhanced Fujita scale, we're talking a very strong EF5 tornado, to put it into perspective. So when we talk about wind versus water, typically we're talking about a coastal situation, a storm surge event. And with storm surge on the coast with the ocean, you have waves. Most of the wave characteristics we're going to discuss here, the most severe are breaking waves, and the heights are going to vary by flood zone. Typically in your V zones, these waves can exceed 3 feet. In a coastal A zone, you're 1.5 to 3 feet, and a wave typically travels about 8 to 14 miles an hour. And keep in mind, your wave height is roughly about 55% of the depth of water it's on. Waves are particularly dangerous due to their cyclic and repetitive nature. I mean, think about it. When you're out at the ocean, the waves are coming one after another after another. Typically, waves are happening about every 6 to 12 seconds. So in the period of an hour, you're looking at 300 to 600 waves. Just imagine a building standing there taking that kind of punishment over a period of hours of a hurricane. Now with wave run-up, that occurs as the waves break and they run up the beaches. You see this a lot at the beach where all the smaller kids play in the shallow water that ebbs and flows. This drives large volumes of water inland, and it creates drag forces on buildings or any kind of obstruction in its path, which can cause localized erosion around those buildings. The run-up along a vertical surface typically forces water upward due to the sudden termination and is much stronger than just the impact. Think about some of those great pictures they show on the Weather Channel, those videos of the nor'easters with big waves slamming those seawalls up in Boston. Makes for great television, not so much for the building. So when we talk about wave characteristics, here's a cross-sectional view of a typical coastline. You see the still water elevation on the right, your breaker depth, that's at 55% we were talking about earlier, your hypothetical slope, and then we have the limits of the wave run-up to give you an idea of where we're talking about how these things occur on the beach. So when we start talking damage, with wind, typically wind forces are greatest at the top. Makes sense, right? When you do a wind investigation, typically the first thing you want to go look at is the roof. That's where you're going to see the damage first. With the wave or water damage, that's usually going to be greatest at the bottom. The storm surge flow is going to slowly make its way into the property up to its maximum point and then slowly work its way back out. Now with surge in particular, it's very difficult to get that wonderful picture where you have the standing or the ponded water line with that seed line that you can measure, because remember, the waves on the ocean are still occurring every 6 to 12 seconds. So as that storm surge is slowly making its way out of the property, going back into the limits of the beach, those waves are lapping constantly. So it's basically self-cleaning up after itself as it goes. So it's very difficult to find that ponded water line.
Hi, Eric. I have a question for you.
Sure, Danny.
So, when you arrive as an adjuster and you're seeing a constant water line, we could actually have higher water levels due to storm surge, but it's not shown as a standard line or a standard point along the wall.
That's correct.
Okay, so something we need to look for.
Yeah, typically I would estimate from my ponded water line, usually about a 2 foot wave above that in typical situations. It could be more depending on the site, but you'd have to look at the physical evidence at each site. So with hydrodynamic forces, we have moving water, the dynamic portion. It basically, the water moves very much like air. If you're familiar with wind impacting a structure where it pushes on one side and pulls on the other as it goes by, water does exactly the same thing. However, because water also brings with it a lot of debris that can impact the building, and water is so dense, the fact that just the water pounding on the side of the building alone can cause damage and destroy a foundation. You're going to have to look for the site-specific characteristics and the strength of the foundation. Obviously, an older foundation, deteriorated condition is not going to be as strong as a relatively new one, particularly with the new building codes that have been enforced recently. Here's an example of a hydrodynamic force situation. The other thing with hydrodynamic force to look for is a direction of flow. Typically, the water is going to come from one direction and move through the building and out the other side. So all your damage is going to line up. If we look at the next picture, you can see here the previous picture. This was the backside of the house. The bay in North Carolina was directly behind me as I'm taking this photograph. So the water would have been moving toward the back of the house in this photo. And then in the subsequent picture here, this is the front of the house where the water hit the back of the house, moved through the house, and pushed out the block wall that was enclosing the old garage door open. That's a good indication of the directionality. It should make sense to you. If the surge flooding came from the bay, it's going to work its way from the back to the front of the building. It should make sense and line up. If it doesn't, you may want to look at maybe there's something else going on.
I have a question for you, another one.
Sure.
Okay, so if we're looking at this building right here and we have piers, so it's an elevated structure.
Yes.
And when you look at the storm surge, you're going to see movement at the bottom. So you might see these piers leaning at the direction where the water was going.
That's correct. The important thing to realize there, especially with a pile supported building, you want to look for plumb measurements where all of the piers, all the piles are listing consistently away from the direction of the water. So if it's on a beach situation, all of the piles should be, the top should be leaning away from the ocean. If a lot of times, remember, when you're driving a wooden pile, they're not perfectly straight to begin with. And the contractors typically allow a 1/4 inch per foot for plumbness. So 1 inch and 4 feet is quite a bit to be in or out. So it's not going to necessarily be perfectly straight to begin with. But typically you're going to find when you look at a bunch of houses or a bunch of piles under a house that they're going to be out of plumb in different directions. So that's an installation issue. If they're all out of plumb with the top leaning in the same direction, now that's something that could be caused by the water.
I think that's excellent advice.
Yeah, we see a lot of those all the time when you get a coastal event where everybody, oh, my piles are out of plumb. Well, they've always been like that. Now, when we talk scour, you can see in the photograph here, this is bank erosion wearing away. You know, the water in the river comes up, or the wave action working around the corner of a building is going to dig in and erode the soil. You see a lot of this, particularly in rivers where the deeper holes are on the inside of the curve, where the water speeds up, or on the outside of the curve, excuse me, where the water speeds up. And on the inside of the curve is typically the sandbar areas where you camp, because as the water slows down, it drops all the sediment load and creates a sandbar. Keep in mind, too, that a lot of this type of scour and erosion is not just the water. It could be other abrasive particles in the water. Pebbles, stones, debris, all that kind of stuff that can abrade and scour the surface as the water pushes past it. Here's a good example of scour. You can see on the photograph the dark line on the foundation just below the chimney and below those basement windows where the ground surface used to be, and now it's not. And that's about, I believe, about 5 or 6 feet depth from the base of those windows on the gray house down to the ground level. So there's quite a bit of erosion happening here.
I have a question for you.
Sure.
I would say this would be water because I'm looking at the roof and I have no shingles missing.
Exactly. But your chimney's gone.
No, but that could be done by the interactive forces from the wave, actually moving it and then taking that brick building or whatever and then crumbling it.
Yeah, I would say you're exactly right. Looking at the photograph, that corner of the house, it looks like the foundation for the chimney is missing. The chimney itself has collapsed and pulled away from the building. And for these folks, it's a good thing the chimney fell away from the building rather than onto the building. Here's a good example of velocity flow. This is the house next door from the one we just looked at. If you look in the foreground of the photograph, the right side, there's a little piece of foundation wall still standing. That used to be the front wall of that house, the right corner that you see. That used to be where the house was. It's moved back about 100 feet from where it used to be. And again, notice the vegetation. The trees are all have their leaves. They're standing relatively vertical. Look at the detached garage back there. Shingles are still intact. Shingles are still intact on the house next door. This is all from a flood event. Now, also keep in mind, the flood event can bring with it a lot of debris as it flows and picks things up. Here in the photograph, you see some pilings from a house that was destroyed, pushed through the breakaway walls of the house in the background there. It can pick up all kinds of things. The water can pick up cars and debris, bits and pieces of buildings, sheds, trampolines, all kinds of things. The other thing to keep in mind too is don't just look for debris outside the house. Keep in mind, in certain parts of the country where basements are prevalent, they have heating oil tanks that are supposed to be strapped down, but not necessarily strapped down well, or if at all. And when the basement fills up, those things can turn into just basically fishing bobbers and bounce around, causing all kinds of problems. Also, think about other things in the basement. You're going to have refrigerators floating, washers and dryers, things of that nature. All those things become debris floating around in that isolated part of the basement, and they can knock into interior columns and different things, causing structural damage inside as well as outside of the house. So when we talk storm surge, the water is pushed on shore as a combination of the wind and the pressure differential from the storm event. You see here in the picture, the lower line is the mean or average sea level. Then we have a normal high tide line. And then you get in with a 15 or so foot surge, and then there's an additional surge on top of that from your wave action. So typically the water doesn't come all at once. It's not a 15-foot high wall of water that moves on shore. It comes ashore gradually over time. Now that, depending on the speed of the storm, that can be gradually as a matter of hours. It could be as short as an hour. It just depends on the speed the storm is moving and how fast that water is building. And also keep in mind the topography of the ocean floor, the topography of the bays. Certain areas, depending on the wind direction and the storm direction, may be more affected by the storm surge than other areas.
Did you know that the highest storm surge was a result of Katrina? And they're reporting it at 27.8 feet.
Wow. Yeah, that's a lot of water. Almost 30 feet of water. Now, this picture depicts what's called a slosh map. This was put out by NOAA and FEMA some years ago. This is an older map. I haven't seen an updated one yet. They were supposedly working on one similar to this for the East Coast. But if you look along the lower axis, the horizontal axis, you'll see that we start off with Galveston and we work our way across to Longboat Key, Florida. Those are points along the Gulf Coast of the United States. And then going vertically, we have 0, 5, 10. Those are storm surge elevations. The different lines indicate the category of hurricane. So on a category 1, we have the lower yellow line, and category 3 is the middle line, and a cat 5 would be the red line at the top. So if you're looking at the bottom of the of the graph, you'll see about, near the middle, it says Bay St. Louis. And if you go up and follow that line up to a Cat 5, that's about 30 feet. So a Cat 4 would be somewhere in between there, maybe say about 25, 26 feet. And doing some work over there after Katrina, I would say that's pretty close to what they saw. So this map is somewhat accurate. If you go down to the right a little bit further, you'll see Mexico Beach, Panama City. And if you follow that line up, a Cat 5 storm is about 20 feet. And from recent numbers that I've seen on Mexico Beach, it was around 18 to 20 feet surge that they had. So the numbers predicted here are fairly accurate. Now let's look at some photographs and talk through some things, what we look for. When we go out here, and this is the site, what are we thinking here? Wind or water? Because looking at the slab, everything's completely removed. Everything. There's no walls, no interior walls, no nothing left. You got some bits and pieces of brick veneer laying on the slab. The floor tile looks fantastic, but that's it. But take a look at the trees. The vegetation looks pretty good. We don't see any trees down or leaning or listing or anything like that. So this one's going to be a lot of water damage.
That could be a little misleading because your wind will also bend your trees, but also wave surge would also bend as well.
Exactly. Here's another photograph. Let's take a look at this one and see what we see. Again, your trees are looking pretty good, but take a look at the house roof that's crumbled laying on the ground to the left. Notice that most of the shingles are intact. The siding on the gable end there that's exposed is intact. All of our fascia that we can see, with the exception of a little bit at the right end, is intact. We have a little bit of shingle damage at the right corner there. I would attest that given the destruction here and a little inside information that I have on this file, this is primarily a flood event where the building walls collapsed, and the damage to the shingles in that corner are due to subsequent wave run-up after the building collapsed and the surge was still present. What do you think about this one? Again, we've got a roof slope, the collapsed building, but take a look at the slope. That's a pretty good looking 3-tab shingle roof for just going through a category 4.5 or 5 hurricane. And take a look at how far that tree is driven through the roof sheathing and decking. This one is definitely a water event. However, you're going to have a little bit of wave action to force that structure around that tree in such a manner. Now let's take a look at this photograph. It's a little bit different. Notice the vegetation. We've got an uprooted large tree on the right side of the photograph. Look at the wind profile of the damage to the roof that you're seeing. You've got a lot of shingles missing, primarily at the ridge and the gable end along the eave. Look at that parking job of the car to the left of the little house there. Looks like that fella had quite a rough night if that's where he left his vehicle. This one is all wind. There's no water damage here. This was after a tornado in Tuscaloosa in 2011. Now let's take a look at this building. It's a different type of construction. Obviously, this was an elevated house up on some concrete piers. Notice, have a look at that metal roof system and the siding on the building. We don't have any damage up high. None of the soffits are missing. None of the fascia is missing. The windows aren't even broken. This house was attached to these piers. In fact, the front wall of the house that you see in the photograph was actually behind me when I'm taking this picture. And the row of piers that's leaning over there in the foreground was actually the center bearing wall in that house. This is all flood related. This is all surge related from Hurricane Michael. Now, what do you think of this one? Again, somebody started cutting some trees up here. There's no leaves left on the tree that we see standing. It looks like this house was hit by something. You notice the roof line at the eave is a little out of level there. But again, look at the damage to the roof structure and on your way down the wall. And notice that the wind damage is primarily on the eave of the gable end, pushing backwards. which is where we'd expect to find the wind damage in that pattern along the eaves, the ridges, the discontinuities in the roof line. Now, this one I put in just as a discussion point. You see some shingles damaged here. The building's collapsed. Notice we got two roof coverings on the building. We have the original roof covering underneath a subsequent roof covering. This particular building was damaged by flood. You notice the concrete sections of boardwalk that have pummeled the front of the building from the surge and caused the collapse of the building. And the shingles here that are missing, the building collapsed during the flood event, and subsequent wave run-up tore the shingles off of the roof. That had nothing to do with wind. Because look at the top of the building near the ridge at the upper left of the picture. Notice those shingles are intact. Even the ridge vent itself is intact. So we don't have any wind damage. This is just the battering of the debris, like we talked about earlier. In this case, these unreinforced slabs of concrete that were about 50 yards in front of this building were picked up by the surge, battered into the building, causing it to collapse, and then subsequent runoff peeled the shingles off.
But the actual damage on the top of the ridge is basically the result of the roof falling.
Yes.
And then that pressure pushed up,
Right.
and then that's the resultant damage.
Yeah, this one has a small fireplace inside. That's why you have the high spot toward the back portion of the ridge. That's the chimney has broken off as a result of the building collapsing, and the house has kind of rotated around the chimney, and that high spot in the back is actually the remnants of the chimney holding the house up. Now take a look at this one. I put this one in again. This is another tricky one. Notice the damage to the building, the damage to the roof section. We've got a tarp on the roof. We're missing all kinds of siding. This thing looks like somebody put it in a blender. But the important thing to notice is look at the corner in the foreground of the photograph there. And notice that corner was a little further to the left, sitting on that brick perimeter stem wall. Now, is this wind or is this water? Because typically water is going to move the building off of its foundation, as we saw in earlier pictures. But in this case, this house was pushed off its foundation by wind. This is all wind. Again, this was a tornado in Hattiesburg a few years back, and this house was pushed about 4 to 5 feet off of its foundation because of the tornado.
You know what I'm also looking for? No water line, and look at your siding.
Yes. Yeah, there's no damage to the siding down low like you typically see from a wave or water action peeling it off. Now take a look at this one. These are elevated houses pushed over. The one on the right definitely had an issue and fell into the one on the left, which fell into the one on the very left. What do you think here? We've got a lot of siding missing. Keep in mind, I was in the house on the far left, and I can tell you that there was no water line inside that house.
I'm thinking probably a wind event.
That's exactly what it was. Wind event is what happened here. This was in Mexico Beach. The face of the houses that you're looking at, the elevation in the photograph is the south elevation, so the Gulf is behind me. And this was indicative of what we were seeing on that side of the storm. The winds came from the south and the east when Michael made landfall here. And all of these, the building on the far right suffered what's called a short story failure and collapsed. And when it collapsed, it fell into the building next to it, causing a similar failure, and so on and so forth.
Another thing that I'm also noticing, this is an elevated structure. No siding, so the water would go underneath it and free flowing.
Yes. Now, I wouldn't necessarily say free flowing. Some of these had small enclosures with breakaway systems underneath. So if you put any kind of vertical wall below that first elevated floor, those are mandated to be breakaway systems, so you don't create an impediment in the floodway. Which I can tell you, after Michael, we saw a lot of them that didn't break away as such because the owners in previous years had made so-called improvements to strengthen those walls. And when they did finally give way from the flood, they took a lot of floor framing and issues upstairs with them as a result.
That's an excellent point.
Due to those altered designs and altered connections, when they stiffened those connections, when the failure did occur, rather than just the lower story wall breaking away like it's supposed to, it also tore out floor members upstairs, which caused subsequent collapses of the upper stories. Let's take a look at this one. This is again a nice church. Obviously, it's got some issues with the roof, and you see some windows blown out there on the left side. Take a look at the steeple on the church. I don't know if you can see it real well, but if you notice, there's a lot of the greenish colored copper flashing is missing from the steeple. I can tell you from experience that there's about 65 to 70% of the copper flashing missing from that steeple. And notice the substantial damage to the roof. You've got a large section of the roof missing, not only the shingles, but the decking as well. And again, look low. There's hardly any damage at all to the brick veneer or any issues low. On the right side, just beyond those storage containers, you see the lower story windows are intact. This is all tornado damage. This again was in Hattiesburg in, I think, 2013. Now, what do you think of this one? Here's an interesting one. We've got a complete collapse, but notice the awnings, the little canvas awnings are still attached to the dormers on the house. So clearly we didn't have a lot of wind. Otherwise, those would be 2 or 3 counties away. Notice on the gambrel roof, we don't have a lot of shingles missing or any shingles at all. On the house next door, we don't have any shingles missing. So this one would be all flood. In fact, this was an area where the water swirled for about a day. And as it did, it caused the collapse of the foundation wall, and the building collapsed as a result.
I have a question for you.
Sure.
Since you mentioned it was flood, but could it also be sinkhole?
Not in this part of the world. In order to determine whether or not it was a sinkhole, we'd have to do geotechnical testing, which would involve drilling to determine what's going on underneath the ground surface. Again, here's another good example. Take a look at the building. We have all the damages low. In fact, we're missing about 5 to 6 feet of the ground surface. I don't know how they're going to get their mail up to the front door, but that first step is a pretty big one. But again, take a look at the house, the porch roof. There's no shingles missing. There's no siding off of the side of the house. And look at the house to the right. There's no shingles missing on it either. This again was all flood-related damage. Now this is a good example. Take a look at this one, study it for a second, and we've got some siding missing on the back side of the house, but we have no shingles missing on the second floor roof. You've got something going on back there to the left that's stuck up in the pine trees a little bit, and it looks like the block wall or somewhat of a wall footing there in the foreground. I can tell you that this building was damaged by flood. This was a flash flood event in Pennsylvania. The block wall that you're seeing there in the foreground was the detached garage that came off its foundation, and the water was flowing from behind me in the photograph toward that pine tree you see in the background. The detached garage slammed into the addition that was attached to the rear of the house, which tore it off. And the large section of wood framing that you see in the pine tree was the rear deck that snagged about 15 feet up in that pine tree and was caught by the water flow. In this particular house, I was upstairs in the second floor, and there was about 40 inches of water upstairs. So you can imagine we had probably around 15 to 18 feet of water around this house at one time. Now here's a good one. Don't often see houses impeding the highway very often. But again, take a good look. We have a very clean looking roof slope. Very little, if any, shingles missing. Notice that the turbine vent is still on up at the ridge. The porch roof is still intact. The storm door is still intact. In fact, the drapes are still on the broken window. And the fact that the building has become buoyant and floated into the highway. This is all related to a flood event. Now, this one, again, take a look at it. We've got a lot of damage going on here, but again, look at the roof slope. I would challenge you to find a shingle missing on that roof slope. This house, again, look at the siding on the house behind it, directly behind it. You don't see any siding missing off of the house behind it. You don't see hardly any siding missing from the damaged house either, and the elevation that you see. Going further to the right in the photograph, notice the roof surfaces there look fairly intact. The trees are still got a good many leaves on them. They're still vertical. Again, in this particular photograph, the Atlantic Ocean is behind me. So the surge flooding would have come from behind me in the photograph, impacted the front face of the house, and pushed it off of its foundation.
There's a couple of things that I see as well is the accumulation of sand built up. And that's one thing. That would tell me that it's water. Another thing that I'm looking at is the neighbor's house throughout the surrounding area. There's not one shingle off.
Right. No matter what a plaintiff attorney will tell you or a public adjuster will tell you, wind is going to affect everyone in the neighborhood, not just the particular house that he or she represents. And you can notice too, in the left side of the photograph, you see a piece of debris wrapped around one of the piers there. That may or may not be related to water or wind. I mean, again, this is about a week after the storm, so it's hard to use something like that. But the fact that the building is displaced in a manner that is consistent with where the surge would come from, and the fact that we have very little roof damage, this is definitely a flood event. Now, here's a good example of what we were talking about. The wind doesn't just affect one house. You see the house in the background to the left, the gable end's missing, most of the roof trusses are exposed, a vast majority of the roof decking is missing. Look at the house again to the left of that one, you can just see a corner of it. You kind of make out a little window maybe there, and what used to be part of a fireplace going up, or chimney. There's no roof section on that. Notice the tree in the foreground, and notice the tree is kind of rotated, almost like somebody tried to unscrew it from the ground. This is very characteristic of not just wind damage, but tornadic wind damage. You're going to have that rotational force. In some larger tornadoes, I've seen bark spun off of trees. I've seen blades of grass pulled out of the ground. So it's not unusual to see things like that when you're talking about the substantial pressures that you're dealing with here. In one instance, I've even seen the second floor ceiling joist displaced upward in a bedroom, and a king-size comforter sucked off of the bed into the attic from the tornado going overhead.
One question, when you're getting in a tornado situation, you get a lot of pressure from the outside, surface.
Yes.
So when you're on the inside, that is a different pressure, and it could collapse on itself.
It could. Normally what happens is the tornado makes some kind of penetration into the building, whether it removes a window or it gets hit, like a window shatters with flying debris. Typically the larger openings, your picture windows, the garage door, if it's not wind rated, typically those fail first, and then as the house pressurizes as a result of the storm created opening, that's when you start to see is catastrophic damage. It's been my experience. Not if the house doesn't necessarily explode or implode because of a pressure difference, it's usually a result of some sort of opening created and the wind rushes in and fills the building and then causes the displacement. You can see in this picture, this used to be a house. At least I think so. There's a driveway there in the foreground leading up to what I thought was a garage. But again, notice this is in a subdivision. The houses were pretty packed together. But notice all of the trees are splintered and gone. The vast majority of the building here is gone. This is in Moore, Oklahoma after the EF5 tornado a few years ago. And this was indicative of block after block of houses that we went through in the ground zero area.
Make sure you have a GPS.
Yeah, that's one thing. No matter what the catastrophe is you're working, a GPS is helpful, preferably one with updated maps, because there's no street signs, there's no mailboxes, there's no landmarks, and that doesn't even always work, because a lot of times you may be in an area that doesn't have good cell service. I can remember doing flood work in West Virginia a few years ago, where cell service was a premium, maps were off, and you ended up having to find a FedEx driver, a postman, a fireman, somebody that you could ask to get directions, because you couldn't find anything.
Another thing trying to reconstruct this building is go to your building department, see if you get some plans.
That's a good tip if they have them, depending on where you're at. Some of the more urban areas may, and it depends on the age of the structure too, because a lot of times things that are more than 15 years old, the building department purges the files and they no longer have them. Now, if it's a commercial structure, a school, something like that, it's a different story. But typically residential houses after 10 years or so, they're not going to be around. And that's if you can find the building department. There are some rural areas where I think they just got electricity not too long ago. So it makes it difficult sometimes. But this photo is a good indication of what we were talking about earlier about how the structure comes apart. You can see here, the garage appears to be on the left side of that house in the center of the photograph. The garage door is gone. The roof over the garage is gone. And that's a lot of what we were seeing, particularly in Hurricane Michael, was a lot of the same damage. The garage door either was pulled off or pushed in, which allowed wind access to the building, and then it took off the garage wall. It got into the attic surface space there above the garage, took the roof decking off, and then once it was into the attic of the house, the ceilings finishes are the next weakest link to go. And once it's into the house, windows, doors, all kinds of things start happening and breaking.
Do you find that Simpson clips or hurricane straps are important
Oh,
for the
yes.
reconstruction
Oh,
and
yes.
will probably result of saving the roof?
Yeah, I would say so. I've seen a lot of the newer construction with the tie downs, the clips, that definitely helped. A lot of the newer roofs with the secondary waterproofing membrane underneath cut down on a lot of water damage inside. But you can definitely tell the ones that the houses that were older, that hadn't been retrofitted or hadn't been built to today's codes, they suffered quite a bit. I saw a lot of even wind-rated garage doors. People paid thousands of dollars for a wind-rated garage door. However, the garage door wasn't installed properly. They hung the garage door from the old framing that wasn't attached properly. So all you ended up with was a beautiful, expensive wind-rated garage door in a pile out in the yard. Metal roofs, again, were the same thing. If the metal roof was installed properly, it did very well in Michael. If the metal roof was not installed properly, it ended up in a large sheet 2 or 3 houses down. Here's another example of this was the hospital. This is it was a hospital at one time. This was a 3-story building. I believe, I don't know if it's this picture, but I have a picture of, there are 2 cars parked on the 3rd floor of the building after the storm that I don't think they were supposed to be there. But you can notice the extensive damage here. Look at the roof damage or lack of a roof in some areas. Notice the car flipped over on the left side of the photograph. A lot of debris. And this building is, it's clad with eaves, but look at the holes in the eaves and the penetrations and the impacts. This was the hospital in Moore, Oklahoma after the tornado. And this thing really took a direct hit, and it did not do very well at all.
One thing I'd like to add is that you're dealing with steel construction. It's a hospital, so it's really beefed up,
Yes.
supposedly by code.
Yes.
And you can just see that it's just bent like a
Oh, yeah.
toothpick.
All the steel framing is twisted and bent. Notice right there behind the light plant, you see that dark line. That is a rather large steel beam that used to be a structural support of some sort, maybe for an overhang. This building really took a beating. And again, this is a different aspect. This is a concrete building that actually had the stucco in sections pulled off of it. And you don't see this very often. And it's kind of unusual because where would we expect to see typical wind damage would be at the top of the building, not necessarily at the bottom. But this building was up on a bluff, and it was actually struck by a water spout that came off of the bay and turned into a tornado. And as the winds rushed around the side, from the back side of the building around this corner, just like with a roof, just like with a roof, you would have issues with the wind pressure picking up at the discontinuities and causing displacement. Again, take a look at this. We've got pretty much damage up and down. Notice the metal roof is intact on the left side of the photograph, but it's mostly missing on the right side of the photograph, including some of the decking. Take a good look there in the middle of the photograph, that nice piece of metal flashing that used to be up on top, jammed into the building like a spear. There's another piece of flashing toward the left of the photograph you see jammed into the building like a spear. This again is all wind related damage. Notice there's no damage down low, and you've got a lot of high damage. Here again, this one's a little bit of both. Notice the structure out on the water, the roof structure is a little bit cockeyed from the wind. Notice some shingles missing on the ridge there. And look at your dock. We also have some dock members that have been lifted by the wave action on the lake.
For your flood adjusters, it's not covered.
And again, take a look out here of notice the structure. There's no lateral bracing here. There's no pieces connecting the piles or the poles to the supporting horizontal members of the roof. So that makes the structure inherently unstable, and when you get enough wind, it will rack the structure. And again, notice the wind damage here. This is the house, a view of the house before Hurricane Matthew, and this is what the house looked like after Hurricane Matthew. Notice the back side of the roof slope is blown over the house, and here it is from down below. You see the sheet pile wall to my right. There was about 12 to 15 feet of erosion took place under the house from the surge, and which caused the subsequent collapse of the floor slab. But this one also had some damage as a result of wind. However, most of the failure was from the surge itself. Notice too in the right corner of the photograph there, whoever installed the toilet at the slab did a fantastic job, because as you can see here, it's still stuck to the slab.
I have a question on surge.
Sure.
What's more important? What areas does it concentrate on surge? Coastal areas or water, rivers, lakes, streams?
Typically, your storm surge is going to be associated with a hurricane, which is a coastal event. However, depending on the way the wind blows or the way the storm hits, the surge can also be felt up the coastal river that happens to be there. I know if you have like when Matthew went up the coast, Jacksonville and the St. Johns River had a lot of inland flooding as a result of surge from the storm passing by. And here again, you can see the backside of the roof flipped over. And again, more erosion from behind.
Would you say that more damage is caused by coastal surge or from inundation of water coming out of your rivers and lakes and streams?
I would say more damage as far as dollar-wise and what you hear about as public knowledge would be from a storm surge, because those are typically, they're rather isolated events, but they're rather large events that you hear a lot about. There are a lot of inland flood events that you hardly ever hear anything about. But I would say it's about the same. Now, this one's a unique case study. This is what the house looked like from Google Earth before Hurricane Michael, excuse me. It's about 250 feet from the Gulf. And this is what it looked like when I got there a week after the storm. So how do we tell what's wind and what's surge? That's typically what I'm tasked with doing. And here, there's not a whole lot to work with. But we do see that the elevated structures that were between our house and the Gulf still survived. They're still intact. They're missing a lot of siding. They still got some roof on them. So we know we got some wind, but how do we tell how much water was here? Well, we start poking around. We could tell by looking at what's left of our structure. It was wood framed because you notice the anchor bolts still sticking out of the slab and the 2x4 walls that you can see the base plate of there. So we know it's a slab on grade. It's about 10 feet above sea level here. We know there was wood framing. We see remnants attached. Both the first and second floors were wood framed. This isn't some kind of construction where the first floor is block, the second floor is wood. We know what the shed roof slopes look like. We know they were covered with shingles. We know we've got elevated structures that have wind damage between us and the Gulf, but we need some help. So we spiral out. Typically, I like to go in a clockwise direction from the center of the house that I'm looking at and start looking for clues. I look at the underside of those properties between me and the Gulf of Mexico and find out if there's any flood damage or water lines or anything like that, or any debris wedged into foundation elements. Notice here on one of the houses between us and the Gulf, this is a floor beam that's been damaged consistent with impact from flood. This is about 12 feet above grade. And again, notice the marsh grass wedged into some of the pile connections for the lateral support. Again, about 12 feet above grade. Same thing here. You've got some grass that's actually tucked under that old corroded clip. And it isn't something that was blown in there. That had to be forced in by the water. Now, we got to have a timeline because obviously, which came first, the chicken or the egg? Did the flood happen first? Did the water happen first? These can be specific to an address or just a location. The problem with this, it takes time to get this information. If you're out there 3, 4, 5 days after the storm, you're not going to have this. It takes about 4 to 6 weeks for CompuWeather to generate all the information, to compile all the USGS field reports, all the NOAA data, all the wind data from everywhere around, and try to put together a what happened scenario. And this is what the product looks like when you get it. These are different for every storm event, for every location in different storm events. It breaks it down. You can see by the time at the bottom of the graph. And then we have our water elevations at the bottom, the little bars that show the height of the water. And we have the black diamonds show us the maximum sustained wind, and the yellow cubes show us the maximum gust. So about the time, the peak of the storm, when we have a 16-foot surge, we also have about 180-mile gust. So this gives us some idea of how the water approaches and how the wind approaches. But notice as we're going, about 11 a.m., we've got a 7-foot surge already happening.
Is that derived from the buoy markers out there too that you can check and see
Yes.
what the height of the buoy markers are, what the normal is, and what you see happening on the storm? And they have a website that you could go to and check those buoy markers as well.
Well, this takes into consideration not only the buoy markers, but the USGS data that's collected for the flood mapper site to show you all the different storm surge heights that were physically measured. So you have a really good idea from this based on all that information that's dumped into here to what actually happened. Now with Katrina, the wind field was a little bit wider. The storm wasn't as compact. It didn't move as fast. With Ivan, it was a little bit wider storm event as well. So each storm has its own personality and its own characteristic. But you see here at 11 a.m., we're at 7 feet of water already. So our house has already taken on water, and the winds are only 67 miles an hour at the gust. That's no more than a typical Florida storm. So you're probably not losing any shingles. Everything's doing well, but we're getting wet inside. At 12, we've added another 4, almost 5 feet of surge. So now we're up to probably getting close to the second floor getting wet. Well, if the first floor is submerged, is it going to be affected by wind? No, it can't. It's underwater. So by the time the surge gets above the second floor at 16 feet, the wind's at 155 miles an hour. At that point, your second floor framing's gone, your roof slopes are gone, most of the shingles, the roof slopes themselves, let alone the shingles, are gone. So in this case, what ends up happening, we know how the wind affects the building and where to look for the damage. But the timing of the water, which came first, the water was about 8 feet, 9 feet deep when the second floor came off. So likely what happened here, the south wall of the first floor deflected by wave, caused the building to collapse, and the rest of it was destroyed by wind. And the surge, as it retreated, scoured the site clean. So based on a review of the remnants, this is what we can figure out from that extra help that we got. And again, the displacement of the first floor walls and removal of debris was from flood, and the rest of it was The second floor was taken off, in this case, primarily by wind. They're not always this easy to separate out, but in this case, based on the timing, that's what happened. And here, one extra one. Again, notice the wall missing, but the shingle's intact. And I can tell you this is from flood. Well, because I had a picture in there showing that there was about 6 feet of water in that garage. But that's all I have. If y'all have any questions, feel free to let us know.
All right, thank you so much, Erik. That was very informative, very great pictures. Definitely feel bad for those homeowners. Hopefully their insurance covered it. So right now we're just going to open up the floor to any questions for either Danny or Erik. So if you have any questions, please use the Q&A feature that we have there. It can be anything about hurricanes, anything that we've talked about, anything. Feel free to do that. We don't have any right now, but we're going to give you guys just a couple of moments here if you are typing up those questions. And a question that we do get a lot is, it's going to be recorded, and yes, in about a couple of days we'll be sending a recording of this webinar along with the survey, and in the survey is going to ask you some questions about what you thought, and it'll also give you an opportunity to give us any feedback for future webinars as well too. And if you do have any questions for us, our information's down there, info@simsol.com, and our phone number.
Where can you order the wind and surge reports? CompuWeather.com is where I get them from. That package that I got right after the storm, they provided me with 2 updates subsequent as they got more data in, and they run about $700 to $900 depending on the site. If you want like a general town, it's a little bit cheaper. If you want a site-specific address, it runs a little more expensive.
All right, that concludes our Q&A and also our webinar. Again, we're going to be sending out a recording of this in about a couple of days. Again, thank you so much for attending. We really appreciate it, and we look forward to future webinars. Have a great afternoon, everyone.